This is the explanation for the section 2C on further expansion. In this section, we're going to expand more than just a binomial times a binomial. Remember that a binomial is an expression with two terms, 1, 2, because by equals 2. So if we talk about a trinomial, if it says tri in front of it, then that's going to be an expression with three terms. So here I have 3 times a trinomial because it has 1, 2, 3 terms. When we expand something like this, we do it just like before. We take this and multiply it by everything in the brackets, just like the distributive law. You may have remembered seeing this before. So 3 times x squared plus 6x minus 12. And that's all. Okay? If I now have x plus 3, it's half the same thing. I multiply the 3 by everything in the brackets, but I also have to multiply the x by everything in the brackets. So start from the beginning, and now you maybe start to see why a former student called this the rainbow method, because it starts to look more and more like a rainbow, only we have a down rainbow, a rainbow upside down as well, because we have to do the other one and it gets a little crowded up there. So x times x squared is x to the 3. X times 2x is 2x squared. X times negative 4 is minus 4x. Maybe it helps you to draw these rainbow lines, but then I would do it one at a time rather than all at the beginning. Then do it as you go, then you know which ones you've already done. Okay, and now we get exactly what we got up here when I do 3 times everything else. 3x squared, 3 times 2x plus 6x, and minus 12. The difference here is I might have some like terms that I can join together. So I'm going to look for things that have the same variable combination, like for example this one and this one. They're both x squared terms. And then I also have this minus 4x and this plus 6x. Remember to take the sign in front of the term along with it. If it's a minus, then it's got to come along with it. So really I should have done that for the 2x squared. Okay, switching back to blue. So we have x squared, sorry, not x squared, x cubed out front. Then the x squared terms, 2 plus 3 is going to be 5x squared. Minus 4x plus 6x is plus 2x. And then minus 12. All right, that's all there is to it. Let's do one that's a little bit more complicated. Here I actually have 3 terms multiplied by, 3 expressions multiplied by each other, a lot more terms, 3 expressions, a monomial, just a single variable, a binomial, and a binomial. I find these easiest to start from the back, but you can actually do it in any order you want. You could do x times x minus 1 and then take that answer and multiply it by x plus 3. But I like to start with the back because I find that works a little bit easier. So I'm just going to leave the x out in front to begin with. And then start here with the binomial times the binomial. X times x, x squared, then the outside terms plus 3x. Inside terms, minus 1x is just minus x. Minus 1 times 3 is minus 3. And now I'm not quite done because I still have this x out here. I could first add these like terms together. Let's do that first because then I'll have fewer things to multiply. So x squared and 3x minus x is 2x minus 3. And now I still have to multiply everything in the brackets by x. So I get x cubed plus 2x squared minus 3x. Okay, I could have done the x by everything here and then added like terms, but this way I think is slightly easier. Okay, the last example, we're going to again start from the back. Now I have 3 binomials multiplied together. To do them one after another, so I'm going to start with these 2 and just leave the x plus 2 out front. X times x is x squared. X times 3 is 3x. Negative 1 times x is negative x. And negative 1 times 3 is minus 3, just like I had before. Okay, then again, it's a little bit easier because you have fewer things to multiply if you first collect like terms. So I'm going to write out the exact same thing, but I'm going to collect 3x minus x to make 2x. Before I multiply. Now I have to multiply everything in this binomial by everything in that trinomial, and that looks a lot like this problem over here. Yeah, same kind of thing. So x times x squared is x cubed, and here's where I'll say, okay, I did that one. Now I'm going to do this one, plus 2x squared. Now I'm going to do this one, minus 3x. Then this one, plus 2x squared. Then this one, plus 4x. And 2 times negative 3 is minus 6. Okay, don't have to draw the rainbow lines, but at the beginning it helps to keep track of what you're doing. Then like terms are going to be this x squared term and this x squared term, and then also this x term with the minus sign, and this x term. So as a final answer, I x cubed, 2x squared plus 2x squared is 4x squared, minus 3x plus 4x is plus 1x, or just plus x, and then minus 6 at the end. And that's it. Okay, one last topic to go over, and that is the number of terms. You might have noticed when we do a single number by a trinomial, we end up with 3 terms. 3 little bits multiplied or added together. If I do 2 terms by 3 terms, then I end up with 1, 2, 3, 4, 5, 6 terms. And here, 1 times 2 times 2, I ended up, we didn't actually quite show this, but because I added the like terms here together, but if I had done it like this now without adding like terms together, there would have been 1, 2, 3, 4 terms. This is the number of terms before you add like terms together, just from the actual expansion. And over here, when I expanded everything together, I would have had 2 times 2 times 2. Before expanding, that would have been 1, 2, 3, 4 by that one, and 1, 2, 3, 4 by that one. This would have been 8 terms before joining together. So if there are no like terms, then you always take the number of terms in the one part multiplied by the number of terms in the second part. So this will give you 2 times 3. This is going to give you 6 terms in total. Here nothing will be like terms because they're all different letters, so I get AC plus AD plus AE plus BC plus BD plus BE. And there's nothing in common there. There's no like terms. They're all slightly different. So 1, 2, 3, 4, 5, 6 terms. Okay, that's it. Good luck with your assignment.